Inverse trigonometric functions. Let's recall inverse functions. When the function f is from a to b, a is the domain for the function, b is codomain or range. So when this function is 1, 1 and on to, then inverse of the function exists, denoted by f inverse. So f inverse is from b to a. This f inverse is also 1, 1 and on to. So when f is from a to b, f inverse will be from b to a. So domain of f is equal to range of f inverse, and range of f is equal to domain of f inverse. Now let's consider trigonometric functions. Suppose fx is equal to sin x, then we know that the sin x function is many to 1. Now in order to get 1, 1 function, we restrict the domain to the interval, closed interval, minus pi by 2 to pi by 2. So domain for the function sin x function is minus pi by 2 to pi by 2, and range is, if you consider any value between minus pi by 2 to pi by 2, we will observe that sin x can take any value between minus 1 to 1. So range is closed interval minus 1 to 1. So if the function f is from interval 1 to interval 2, what is the first interval? Interval 1 is closed interval minus pi by 2 to pi by 2, and interval 2 is closed interval minus 1 to 1. So in this case, set A is nothing but interval minus pi by 2 to pi by 2, and set B is nothing but interval minus 1 to 1. So what can you say about f inverse? So f inverse will be from minus 1, 1 to minus pi by 2, pi by 2, right? From B to A. So let's consider, or rather let's recall this graph of sine inverse x. Yes, so domain for this is the graph for sine inverse x, and you know how to obtain this graph. Once you know graph of sine x, you can easily find graph of sine inverse x by flipping it across the diagonal. That means we consider image across the line y is equal to x. So domain in this case is interval minus 1 to 1, and range is from minus pi by 2 to pi by 2. So y belongs to closed interval minus pi by 2 to pi by 2. What do we mean by this? That means y can take value from 0 to pi by 2 or 0 to minus pi by 2. Now 0 to pi by 2 means first quadrant, and 0 to minus pi by 2 means fourth quadrant. So in this case, y can lie in the first quadrant or in the fourth quadrant. Next graph is for y is equal to cos inverse x. Now in this case, domain is same. So this is the graph for y is equal to cos inverse x. You will observe that domain is same, minus 1 to 1. Domain means x value. So x can take any value from minus 1 to 1. But y can take value from 0 to pi. Y belongs to interval 0 to pi. That means y can take value from 0 to pi by 2, that is first quadrant, or pi by 2 to pi, that is second quadrant. Clear? So in case of sine inverse x, you are finding sine inverse x means what? You are finding the angle. So sine inverse x, so you are finding the angle, you are finding y. So y in this case can take value from minus pi by 2 to pi by 2 to pi by 2. That means y value will lie either in the first quadrant or in the fourth quadrant. But in case of cos inverse x, y will lie either in the first quadrant or in the second quadrant. I hope these two graphs are clear. These are the main basic graphs. So if these two are clear, remaining graphs you will be easily it can be easily understood. So we'll proceed with the next trigonometric function, that is fx is equal to tan x. Again we know that this function is what type of graph this function has. See, this is the graph for function fx is equal to tan x. Again we have many to one correspondence here, right? Many one function. So we want to make it one to one. So we'll have to restrict domain. So domain is restricted to open interval minus pi by 2 to pi by 2. Now we are not considering endpoints. Why? Because at the end points this function is not defined. Function does not exist at x equal to pi by 2 and at x equal to minus pi by 2. So excluding endpoints. That's why we put this open bracket here. Now where is this interval minus pi by 2 to pi by 2? This interval, right? So this particular branch we are going to consider. Yes. So by restricting the domain we get this branch between minus pi by 2 to pi by 2. You know that in the first quadrant, that is 0 to pi by 2, it takes value from 0 to infinity, right? Infinite values it takes. And in the fourth quadrant, 0 to minus pi by 2, it goes towards minus infinity. Now to get graph for inverse, by flipping along the diagonal. So by flipping along the diagonal, see, we get this graph. Diagonal is here, line passing through the origin, y is equal to x. So flipping along the diagonal we get graph for the inverse function. This blue one is the graph for the inverse function, inverse of tan function. So fx equal to tan inverse x, or it is also denoted by arc tan x or inverse tangent of x, is this graph. Domain is whole set of real numbers, right? X can take any real value, but y can take any value between minus pi by 2 to pi by 2. Now what are the remaining functions which we will have to discuss? Remaining functions are fx is equal to cosec x. Graph for fx equal to cosec x is like this. This is the graph for fx is equal to cosec x. You will observe that, see, at x is equal to pi by 2, when x is equal to pi by 2, what is the value of cosec pi by 2? It is 1. At x is equal to minus pi by 2, its value is minus 1. So value of cosec x can be 1 to infinity, or it can decrease from minus 1 to minus infinity, right? Next graph is for fx is equal to sec x. Now we know that value of sec 0 is 1. Then when you consider this first quadrant 0 to pi by 2, you will observe that values increases from 1 to infinity. Fourth quadrant 0 to minus pi by 2, again it increases from 1 to infinity. Then second quadrant pi by 2 to pi by 2 to pi, all negative values. Second quadrant all negative values decreases minus 1 to minus infinity. So this is the graph for fx is equal to sec x. Next one, fx is equal to cot x. This is the graph for fx is equal to cot x. When x is 0, it is going towards infinity, right? Now all these are many one types, so we want to restrict the domain so that we will have one function, right? One type. So by restricting the domain to close interval minus pi by 2 to pi by 2 minus 0, because cosec x is 1 upon sin x, and we know that value of sine 0 is 0. So, that particular point we will have to exclude, because at this point this function is not defined. So, x belongs to minus pi by 2 to pi by 2 minus 0. Next, domain for sec x, interval is 0 to pi minus the point pi by 2. So, here pi by 2 will have to exclude. Interval from 0 to pi, see here we have considered minus pi by 2 to pi by 2 and minus 0, this point is excluded. Whereas here for the next graph, that is sec x, we consider interval from 0 to pi. So, this graph and this graph. This graph and this graph. Okay. For cosec x, this graph and this graph. Fine. This is for sec x, 1 to infinity and minus 1 to minus infinity. Now, for cot x, restricted domain is open interval 0 to pi, interval 0 to pi. So, this particular branch we consider. Okay. So, branch for cosec x is this and this, branch for sec x is this and this, branch for cot x is this one. Now, using this we want to find graphs for inverse of all these functions by flipping across the diagonal. So, we get see the graphs now. For cosec inverse x, domain is r minus open interval minus 1 to 1. So, it is not defined between minus 1 and 1. Remaining all points the function is defined. So, domain in this case is r minus open interval minus 1 1, range is close interval minus pi by 2 to pi by 2 minus 0. And this is the graph for cosec inverse x. For next function, f(x) is sec inverse x, domain is x belongs to r minus open interval minus 1 1. See, again we have excluded in between points here. Range is close interval 0 to pi minus excluding one point, that is pi by 2. And this is the graph for sec inverse x. See, it is going from minus 1 to minus infinity and 1 to infinity. In between points are not there. Okay. Then f(x) is equal to cot inverse x, domain is whole set of real numbers, all values it can take, and range is open interval 0 to pi. So, let us recall ranges of the inverse trigonometric functions. When we consider interval minus pi by 2 to pi by 2, that means first quadrant and fourth quadrant, we get values for sine inverse x, tan inverse x and cosec inverse x. So, whenever you want to find sine inverse x, tan inverse x, cosec inverse x, so in all these three cases your final answer will lie in the interval minus pi by 2 to pi by 2. Next, now we have considered interval 0 to pi. So, first quadrant or second quadrant. For cos inverse x, cot inverse x and sec inverse x, your answer will lie in the interval 0 to pi. So, principal value for these three inverse trigonometric functions lie in the interval minus pi by 2 to pi by 2, and principal value for these inverse trigonometric functions, that is cos inverse x, cot inverse x, sec inverse x, lie in the interval 0 to pi. Now, using this you can find principal value for the given values of x. Say for example, you can easily find sine inverse half, cos inverse root 3 by 2, tan inverse minus 1, etc. using this.